Alright, we are back, part 3. Alright, so for question 13, we're given this series right here. N goes from 1 to infinity. It's an alternating series over root n. We want to know if this is conditionally or absolutely convergent. Well, the first thing we should do is just make sure it converges. So that's pretty easy to do. Okay, oh yeah, look, this does. This is an alternating series. If I took the limit as n goes to infinity, we'll go to 0, and it's decreasing. So we're going to repeat our mantra. The series, here it goes, alternates, decreases in magnitude, and the limit equals 0. Therefore, the series converges by the alternating series test. My alternating series. Alright, so we already know that the series will converge if it alternates. So now we're going to talk about the conditionality of this. The conditionality says, okay, I know it converges if it alternates, but what if it was just one sign, positive or negative? So now we test the absolute value. So basically, for conditionality, we are just going to get rid of the alternating part. Get rid of the alternating part. So my new one will be n equals 1 to infinity. And if I get rid of this, this becomes 1 over the square root of n. Now this is a p series. P is 1/2, which is less than 1. So therefore this will diverge by p series. So let's think about what this means for us. That says this series will only converge if the series alternates, if the series change signs. So if the series change signs, we will alternate. But if it does not change signs, this will diverge. So we can say that the series, if you want to, the series only converges if it alternates. Therefore, the series is conditionally convergent. This is all you really need right there, but it's always good to write this down too, because it lets the reader know, hey, I understand what this means. This will only converge if the series alternates. Now what is the difference? Like graphically we can kind of see what that looks like. Something that alternates goes back and forth above and below the x-axis. But something that does not, like this one, it would be like more of a rational function. So we always have to test the conditionality because they're way different graphs. Alright, for number 14, okay, this is our fun one. Approximate the sum to an error of less than 0.001. How many terms are needed? Alright, this is a very good question for us. This is a series. If we write out the series, we would generate a set of numbers. What we're interested in knowing is how many terms do we have to go out in order to have an error of less than 0.001. So there are a couple ways to do this. So I can go ahead and list out the series. N equals 1 to infinity, negative 1 to the n plus 1 over 2n to the 4th minus 1. Now before I begin, I should say my rule. So let me go ahead and scratch this out. We got to say our rule because this is an alternating series. Okay? The series alternates, decreases in magnitude, and the limit equals 0. So what this is saying is we're going to use the alternating series remainder. We're setting it up. The alternating series remainder. Therefore, I can approximate my series. Now I'm going to write this all out. N plus 1 over 2n to the 4th minus 1 equals, ready? If I let n be 1, we're going to get just 1. It's alternating, so I know my next term is going to be negative. Let n be 2. Still going to be 1 on top. But the bottom, this is, what's that? Oh, man. 2 to the 4th is 16 times 2. 35 minus 1, 34. There we go. It's alternating. Let n be 3. If I let n be 3, I already did this for you. You get 1 over 161. Let n be 4, we go minus 1. If you put n equals 4, you get 1 over 511. plus go to the next one, n equals 5, and you're going to get 1 over 1,249. But if I go up here, we want our error to be less than 1 over 1,000. So here we are. This is, remember, this is my next term. So over here, this is already less than 1 over 1,000. We've gone too far. So this is my a sub n plus 1. So this is my next term. So we just back it up, and this is where we can stop. So this would be my approximate value. So we can approximate them. So we can say, therefore, our approximation is 1 minus 1 over 3/4 plus 1 over 161 minus 1 over 511 with an error, because they do tell us an error, with an error of, with our error, r sub 4 is less than my next term, which was this 1 over 1,249, which is less than 1 over 1,000. With our error, with the error of our fourth term is less than 1 over 1,249, which is less than 1,000th of the decimal, which is what they wanted. And you can say, by the alternating series remainder. And there's our answer. All right, the last term question, how many terms do we need? Well, that's obvious. 1, 2, 3, 4. 4 terms were needed to be that accurate. That's all we had to go out. Just go with the 4 terms. We're going to talk a lot about this next unit. Now, if you want to approximate this, you can type this in your calculator. If you want to review that, that's right here. We would go menu, oops, sorry. We want to do the sum of a sequence. Sum of a sequence. Control divide. This becomes -1 to the n plus 1 over quantity 2n to the 4th, 2n caret 4 minus 1, comma n, comma 1, comma, we want 4 terms, and we'll convert that to a decimal, and we get about 0.972, roughly, if you go up 3 decimal places. All right. Now, I think the next part says, what would the, so let's take a look. I think the next part, there's actually one more part to it, says, what would be the range, the interval? So let's go and get that interval here real quick. Okay, if they don't, it's a good question to do it. Remember, that's going to be this s minus s sub n is less than my next term again. So we can just go absolute value of s minus my approximation, which is this 0.972, is less than my next term, which is this 1 over 249. And if you do that, your sum is going to be between 0.971 and 0.973. All right, so I hope you enjoyed these videos. I will see you all later.